Good morning, everyone. I am Vamsi. Our topic is driver drowsiness detection. Coming to the introduction, driving vehicles are complex and require undivided attention to prevent road accidents. Fatigue and distraction are a major risk factor that causes traffic accidents, severe injuries, and a high risk of death. Some progress has been made for driver drowsiness detection using a contact based method that utilizes vehicle parts such as the steering angle, pressure on the pedal, and physiological signals such as electrocardiogram and electromyogram. However, a contactless system has more potential for real world conditions. In this study, we propose a computer vision based method to detect driver drowsiness from a video taken by a camera. So, coming to the motivation behind this project, the morbidity and mortality associated with drowsy driving are high, perhaps because of the higher speeds involved combined with the delayed reaction time. So here is a graph that is showing the time of the day on x-axis and the number of crashes respectively. So time of occurrence of crashes in drivers at ages 26 to 45, in which the crashes were attributed by the police to the driver being asleep, but the alcohol was not involved. So drowsy driving causes most of the accidents in the night. So coming to the approaches. There are several approaches that have been proposed to measure the state of drowsiness of the driver while driving. So they are vehicle-based metrics, psychological metrics, behavioral metrics. So the vehicle-based and physiological metrics are contact-based methods, whereas sensors needed to be attached to the vehicle or driver's body. This is not an easy task to be done in real-world setting and may be like uncomfortable for the driver itself. Therefore, a contact-based method like behavioral metrics is more flexible and suitable for the real-world environment. Most behavioral metrics is measured based on the facial feature analysis. Furthermore, they can be divided into three kinds: appearance-based, template-based, and feature-based methods. Appearance-based methods require a huge amount of data for training classifiers, while template-based methods require expensive computational costs due to a model matching process. In contrast, feature-based methods can monitor driver drowsiness state in a more direct way. The futures can be measured based on eye state estimation, mouth state estimation, and head pose analysis. So coming to the method we used here, we used Euler zones for the detection of the face and the eye. From the detected eye, iris contour is extracted using OpenCV function. To detect drowsiness, we also used Perclose metric. In summary, Perclose has been used as the best potential measure of drowsiness compared to the other ocular metrics. Perclose is the percentage of eye closure during a certain time interval. Coming to the problem formulation part, here we start with histogram equalization. Since the input videos were taken from the real setting, the illumination condition is changing due to the outdoor condition. Therefore, the frame within the video needs a preprocessing method for image enhancement. Histogram equalization method was used to adjust image intensities by redistribution the intensities towards the histogram boundaries. Each input pixel is transformed to a new intensity value based on the cumulative histogram and scale factor. So next coming to the phase and eye detection. To perform fast and efficient computation, we employ Violajon's method for both face detection and eye detection. This method uses integral image representation to compute hair-like features rapidly at many scales. The integral image at any point x comma y contains the sum of all pixels above and to the left of x comma y as follows. So here 2 of x comma y is the integral image and 1 of x dash comma y dash is the original image. So the rapid computation is achieved by constructing a cascade of classifiers which train using adaptive boosting algorithm. So next we do the iris region extraction. From the eye image, circular hoop transformation was used to isolate the iris that is darker than the other areas of the eye that has a circular shape. If Hu algorithm found iris, then edge detection method like Otsu method, Sobel and Canny was used to detect the boundaries of the iris object. So we found that Sobel is better than other edge detection methods. Next, we go to the morphological filters. Here, the edges output from iris extraction contains lines and curves. To measure the area of the iris, there are several morphological operations employed. First, dilation operator was used to adding more pixels to the boundaries of the iris object. This operator uses a structuring element to connect pixels of the iris edges. Then we employed flood fill operation to fill existing holes to reconstruct a better iris shape. Since the dilation operation tends to introduce more pixel boundaries than its original shape, then we employed erode operator. This operator is the inverse of dilation operation that reduces the size of the iris area. So next we do the iris area estimation. Before estimating the iris area, we ensure that there is no noise or small blob existed within the iris region using the Hampel identifier. Then the area of the iris is estimated as the total number of pixels within the iris region. Next, coming to the major thing that is major metric for this project, we are using per close measurement. So per close is a percentage of the total frame that the eye is closed during a certain time interval. The eye is defined as a close based on predetermined per close values. The per close measure is calculated based on the area estimation of iris. We use left iris area, right iris area, and the total of both. Three threshold values, 60%, 70%, and 80%, were tested in this study, and they were referred as P60, P70, and P80. P60 means the percentage of total time that eye is closed at least 60%. Similar meaning was also true for P70 and P80. The per close is calculated as follows. So the next part will be explained by my colleague Saumya Prakash. Thank you.